Okay, let's have a very basic discussion. Suppose this is a target nucleus. Okay, target nucleus. So when I am saying this is a target nucleus, obviously there must be a projectile somewhere. So this is the projectile. So what is going to happen, as you have thought, this projectile is going to come and impinge on the target. Fine. Now, depending on how far the projectile is, different mechanisms of reaction can happen. Let me just briefly explain to you. You see, this is a baryon nucleus, right? So basically there will be a range of strong interaction. Suppose this is the range of strong interaction, right? And what's outside? Outside is electromagnetic interaction. So inside this range there is strong interaction prevalent, and outside there is electromagnetic, and inside not only strong plus electromagnetic interaction. Okay, good. Now if this projectile, let me make it a little bit further. Suppose this projectile is coming. Okay. Now suppose this comes at this angle over here. What do you think will happen? Tell me.
Elastic.
Sir, direction changes.
Don't tell me in terms of, what should I say? Something very with words. Just tell me what will happen to the direction. Don't tell me will the direction remain same or not.
Same.
Let me ask you a question. I am telling you the direction will remain the same. Now tell me, how am I wrong? The direction will not remain the same.
Sir, EM range is to achieve.
English.
Sir, because in the projectile is in EM range.
So the projectile will interact with the target through electromagnetic interaction. Now if there is an interaction, this means that the projectile is already seeing the effect of the target. So since there is an interaction, this cannot remain like this. This is absolutely wrong. Okay. So there are two possibilities in that case. One, either it will go like this or it will go like this. Both are possible. See why? Electromagnetic interaction. Suppose this has got positive charge and this has got positive charge, then what will happen? It will go like this.
Repulsion.
Because of repulsion, right? And suppose this is negative charge, then what will happen? It will go in this path. Because of attraction. Very basic idea. Okay? Now. Okay. Fine. Next step. Suppose this projectile, now it enters over here in this range. What will happen? See? Now it has entered the range where both strong interaction as well as electromagnetic interaction is present. What will happen? There will be some sort of exchange. Exchange of energy as well as momentum. Is it possible? Because it is coming in the range. The projectile is coming in the range, so it will interact by strong interaction. There will be interaction with this. So, what will be the possibilities? First possibility, inelastic scattering. So previously we were talking about elastic scattering, right? Two very interesting cases of elastic scattering. Now this is inelastic scattering, very basic. Next, Suppose again the nucleus comes over here, the projectile just touches the surface. What will happen? Again, here you see strong interaction range, nuclear surface interaction. Now, if I think classically for the time being, what will happen? There are nucleons inside it, the projectile. Also, there are nucleons inside it. Now, if it just touches with this target, then the nucleon, there is a possibility that they just touch one another, touching reaction, and as a result of this touching, one step or two step process, as a result of which one nucleon can get transferred from here to here, or one can get transferred from here to here. So basically this is a grazing reaction or surface type of reaction, where one or two at most nuclei can get exchanged. Say for example, if this is a deuteron, that means proton and neutron, right? It is possible that after interaction, just neutron is emitted. So what does this mean? The proton is absorbed. So what will we call this reaction?
Direct reaction.
Direct reaction, transfer reaction.
Transfer.
Again, types of transfer reaction. Here, proton is being absorbed. What?
Inelastic.
No, stripping reaction.
Oh.
You can say like this, right? What is knockout reaction? Will we say this is knockout reaction?
No.
No.
কারণ স্যার টার্গেট নিউক্লিয়াসে
The knockout reaction example will be different. Suppose this is a neutron coming, right? And here we observe deuteron. That means
So it will pick
it
up the
has
proton
already
from the
picked
nucleus.
up proton as well. So it is a sort of pickup reaction. So these are the possibilities, direct reaction. Right? Now, okay. So suppose now the projectile enters like this. Slowly you see what is happening is that the impact factor is decreasing. Previously the impact factor was over here. So if this is the direct factor, so previously the impact factor was here. That was elastic scattering. Next, the impact factor was inside the range, something like this. You see, even if it comes very close and there is very large Coulomb interaction, then through Coulomb excitation, it is possible. So you can say elastic scattering is a little bit higher in this range, where it is outside the nuclear interaction range, but still close to the electromagnetic interaction is large. There will be inelastic scattering through Coulomb excitation. Inelastic scattering, Coulomb excitation. Next, inside the nuclear interaction range, there is inelastic scattering. But this is nuclear case. Inelastic scattering using nuclear excitation. Now, surface grazing. Here, this is basically transfer reaction. You can say transfer reaction has started or direct reaction has started. Now what happens over here? You see, when the impact factor is again slowly decreasing up to this range, here there is a possibility that this projectile will interact with the nucleons inside the target, and as a result of which, suppose this is my projectile over here, as a result of which there will be transfer of momentum and energy. So it comes with very high energy, it transfers to the nearest nucleon, then the energy is being transferred. Slowly the equilibration process is going on. Okay, energy equilibration. Now suppose after say 10 steps the projectile exits the system, then we will call this a multiple step process. Multiple step process. Multiple step scattering process. And obviously reaction is happening. Here reaction is happening, but through multiple steps. Now you must have heard about compound nuclear reaction. What is that? Compound nuclear reaction is here, lying over here, where impact factor is 0. Why? Because here, if the projectile now, you see, if the projectile hits the target through this area, then there is so much more matter to interact with. That means so much more nucleons to interact with. So as a result, what is the possibility? There is a possibility that the interaction can go on forever, and as a result the projectile will be absorbed by this target system until the energy is equilibrated, and it will just eat away. The target will eat the projectile. Nothing exits the system. But how is it possible? The projectile has come with so much energy. So the energy of the overall target will be increased. The target will be excited to a higher energy level. Excited target, and that is a compound nucleus. Excited compound nucleus. Why compound? Because previously it was a simple nucleus, target nucleus. It has eaten away the projectile, and it has successfully eaten away. It is not giving it away. So now it's a compound system of target and projectile. Compound nucleus having higher excited energy, and then it will decay through particle emission, through radiation, different possibilities. So here we have a compound nuclear reaction. You can say in terms of number of steps, so there it is 1 or 2 step process, multiple step process. Sometimes people call this pre-compound nuclear reaction, and there we have infinite step process until the entire energy of the projectile is absorbed by the system. So this is more or less in terms of the impact parameter.
So there are total 6 cases.
You can say there are actually more, but I am just telling here for the time being 6 very simple cases. Elastic scattering, then inelastic scattering through electromagnetic interaction, that is Coulomb excitation. Next, inelastic scattering, where both nuclear and electromagnetic are present. Here I have written nuclear, but electromagnetic is also present. Next, direct reaction, where there is a transfer of nucleons. Next, there is transfer as well as multiple step interaction. Next, the projectile is eaten away. Galton says.
So how the Coulomb excitation takes place on the second case?
You see, there is electromagnetic, there is a charged particle moving, and this is also a charged particle. Okay, now there will be charged particle interaction through electromagnetic interaction, or through the photon exchange, virtual photon exchange, just how electromagnetic interaction happens, right? And as a result of which, because of this interaction, what will happen is that momentum will be transferred and it will be getting excited. The target will also get excited to some higher level, energy level. But you will say, sir, how will we understand what scattering process or what reaction process is taking place? Now, God has helped us in this matter. What actually happens is that in case of elastic scattering or inelastic scattering, the spectra, particularly the Coulomb excitation and other cases, the spectra is different. Depending on the projectile incident energy, the excited level of the compound nucleus, or not the compound nucleus, the target nucleus is different, and so we observe different level excitation. So in case of, say, if this is the energy level, in case of Coulomb excitation, we will observe these states, whereas in case of, say, direct reaction, we will observe these states. And if both of them suppose happen, we will observe both of them. Okay, so before doing experiment, we have to try to use theory to anticipate this. Otherwise, in the real experiment, we will observing a plethora of superposition of excited levels. And it is a job of a nuclear physicist to decipher this code. This is basically, you have to decipher. This is the code, basically superposition of various energy levels, and from there you have to understand what process has actually happened.